Hey everybody, before we start Chapter 4, I'd like you to watch this short video on an introduction to similar figures so you're ready for what we'll do in class tomorrow. I'd like you to take notes on this in your notebook and bring it with you to class tomorrow. Okay, so copy down the typed print on the screen and let's read through it together. Similar figures are figures that have the same shape but not necessarily the same size. And there's two things that all similar figures must have. First, they have to have corresponding side lengths that are proportional and corresponding angles that have the same measure. So let's take a look at what it means when I say corresponding side lengths are proportional. If you look at rectangle ABCD, you'll see that side AB is 8. And if you look at the corresponding or the matching side on rectangle EFGH, you'll see that it's 4. So I'm going to write the ratio of corresponding sides as 8 over 4. I'm going to do the big one over the little one for this example. And then if you look at another pair of corresponding or matching sides, let's take maybe BC. I see that that's 10. And on FG, it's 5. And what I can see here, you guys, is that every side length on ABCD is twice the length of the side length on EFGH. Okay? So the corresponding sides are proportional. Therefore, these two figures are similar. Let's take a look at these two triangles to figure out if they are also similar. Alright, so the way I'm going to test is I'm going to pick two pair of corresponding sides or two pair of matching sides. Let's look at this side over here, that's 8, and the matching side on the next figure, that is 4. Alright, so I'm going to write the ratio as 8 over 4, and let's see if that equals another ratio of corresponding sides. Let's try, how about the base here, 6. Over the corresponding side over here, the base on the small figure is 3. Okay, there's a couple ways we can test this to see. We could test across, or we could test up and down. And on this one, I think it's easier to test up and down. So I'll say, let's take the numerator divided by the denominator, or let's see how many times bigger 8 is than 4. So to get from here to here, I have to divide by 2. And to get from 6 to 3, I also have to divide by 2. So our ratio of corresponding sides is equal, so therefore we know that so far these two figures do look similar. Let's pick another side just to be sure though that we're right on here. So let's take the hypotenuse here, which is labeled 10, and put that over the hypotenuse on our smaller figure, which is labeled 5. And let's pick another side. It doesn't matter which one we use. Let's go back, how about to 6 and 3, our base. Alright, and again, if we divide the top by the bottom, we'll see that it is, 2 times, divide by 2, 2 times bigger. So all of our corresponding sides are proportional. And the last thing, remember, that similar figures must have is corresponding angles have the same measure. So let's check and see up here. I see that this bottom right angle is a right angle, 90 degrees. Same as in our smaller figure. And then these little symbols here in the corners tell us that this angle and this angle, if you can see where I'm pointing, these two are congruent. They both just have the one line. And these upper two angles are also congruent to each other. They have the 2 lines to show that. That's what that symbol means. So we can say that these two triangles are in fact similar to each other. And that's the sign that we use on this little squiggly line. That's the sign we use to say that they're similar. Alright, let's take a look at one last pair of figures here to determine if these are similar or not. Okay, we'll call this figure 1 and figure 2, just so that we can tell them apart. So let's take a look at our corresponding sides in figure 1 and figure 2. And let's start with this side is a 4. And the corresponding or matching side on figure 2 is labeled 12. So let's do a ratio of those two sides would be 4 over 12. And let's see whether or not that equals the corresponding, another pair of corresponding sides. Since I started with figure 1 on top over here, we'll start with figure 1 for the top of our next ratio. and the matching side over here is labeled 20. So let's check and see if 4/12 is in fact equal to 5/20. Let's see, from here to here. So to get from 4 to 12, I have to multiply by 3. But then to get from 5 to 20, I have to multiply by 4. Since 4/12 is not equal to 5/20, we would say that these two figures are not similar to each other. Even though they're both rectangles, even though they both have 4 90-degree angles, the ratio of the sides, of the corresponding sides, are not proportional. So therefore, these are not similar figures. The very last thing that I want you to do before coming to class tomorrow, so this is your assignment, is I want you to read the introduction to Chapter 4. And you can find that on page 186 in your textbook. And I want you to write down 2 things that we'll be studying in this chapter. 2 things that we'll be studying, or 2 things that you'll learn in Chapter 4. And you can either get that from the introduction on page 186, or you can skim ahead and preview the chapter. Make sure you have that written down with you when you come to class tomorrow, and we will jump into the chapter and start learning more about similar figures. Have a great night. Let's see whether or not these are